Alright, third question from our mixed bag review. Solve simultaneously for x and y. Simultaneous equations, lots of ways of doing this. Obviously your calculator is one. We want to do this algebraically, so we've got elimination and substitution available to us. If ever I have the opportunity to eliminate, I will, because it's just faster. But I'll show you both ways anyway. Here, the coefficient of the x term is the same in each one. So I should be able to eliminate x. Obviously, as they're both positive, what I want to do is take this first equation and subtract the second equation. So if I go equation 1 minus equation 2, and that's just one easy way to make it easy for your examiner to give you marks, whether you're IB, QC, AA, doesn't matter. Someone's marking it, make it easy for them. They'll be more likely to follow your working and give you part marks if you make an error. If you make it difficult, they may not go searching too hard to see where you went wrong. I'm not saying that's right, I'm just saying that's the way it is. So anyway, here we go. First equation minus the second one. When I go x minus x, they disappear. X minus x is 0. 2y minus negative y. When you subtract the negative, take away something negative. Doesn't that make your life better? So it's a positive. 2y minus negative y means 2y plus y. I've got 3y. On the right-hand side, 9 minus 3 is 6. Already this is pretty easy. No real need to show this extra working, but it's good to think about it, so I'm going to show it every time anyway. Opposite of multiplying by 3, divide by 3. To get y on its own, I needed to divide by 3, so I do the same thing to the other side, and I've got y equals 2. Not finished yet, got to substitute it in and find out the value of x. In this case, it doesn't really matter which one I substitute it into. I'm going to say let y equal 2 in equation 2. Looks slightly easier to me, but it's up to you really. Therefore, x minus 2 equals 3. Opposite of subtracting 2 is, of course, to add 2. So x is equal to 5. Nice if you can write a little statement at the end. The simultaneous solution is 5, 2. We could substitute it into each one and check we get the same result for each one. 5 plus 2 2s are 4, 5 plus 4 is 9, 5 minus 2 is 3. Looks like we're right. What about if I wanted to do substitution? Let's show the same thing again using the other method. The easiest one that's going to be nice is I'm going to take equation 2 and rearrange it to make x the subject. So the opposite of x minus y, I want to get rid of that y. The opposite of subtracting y is to add y. I do it to each side, and I've got x is equal to y plus 3. Therefore, substitute sub x equals y plus 3 into the other equation, so equation 1. Therefore, equation 1 has become, instead of x I write y plus 3. It's a good habit to get into to put that in brackets. In this case it doesn't matter, but when there's a coefficient it makes sure you apply it correctly. When there's a negative in front of it, it makes sure you eliminate the opportunity for mistakes, which is what we're trying to do with our math. So y plus 3 plus 2y is equal to 9. We're going to collect our like terms. Y plus 2y is 3y, so 3y plus 3 equals 9. Subtracting 3 from each side, because I want to get rid of that 3. And I have 3y is equal to 6, and you can see we've reduced it to the same problem that we had on the other side after our first line. So after all that work, it's going to follow through the same way. Divide by 3 each side, I've got y equals 2. Follow the substitution method, and we get the same answer. I'm not going to bother doing the rest. I'm sure you can do that on your own, and you've seen the working once already. Hope you got that one right. We'll see you in the next question. Cheers.